is the microcontroller. Okay, और microcontroller में the most widely used is one 8051, which is most popular among all the students and researchers as well. So today in this class, I'll be giving you a glimpse on this microcontroller 8051, and in the next session, after this class, one of our ME student, he has made a robot based on Arduino microcontroller. So he'll be giving you a demonstration what all he has made out of it. So because we are talking of industrial applications, so if we talk of industrial applications of the embedded system, firstly we need to understand what basically embedded system is, what are the components of embedded system, what is a microcontroller, and how to do its programming, etc. So the first question which comes to our mind is, what is a microcontroller? But before we discuss a microcontroller, it's very important to understand that what is the difference between a microprocessor and a microcontroller. Because many of you, as you said that day, that you are teaching microprocessor also. Okay? So if we talk of this PC, you know what is a CPU? क्या होता है CPU? Central Processing Unit. I'm talking of a PC. No, I'm not talking of microprocessor as of now. I'm just talking of a PC. It's a Central Processing Unit. और एक PC में CPU में क्या क्या होता है? You have an ALU, then you have a memory control unit. These are the main components of a CPU. So what does CPU mainly do is, it gets the data from some input device, it processes it, you know, and then it stores the result either in the memory or it displays it as in this case it is displaying in some display device. That is the work of a CPU, all of us are aware of. But what if we make this CPU in the form of a small chip? अगर हम इस CPU की कैपेबिलिटीज को एक स्मॉल चिप की फॉर्म में डाल दें, दैट इज नथिंग बट अ माइक्रो प्रोसेसर, है ना. एंड माइक्रो प्रोसेसर अगर हम बात करते हैं तो इंटेल इज द पायनियर. इंटेल कंपनी लॉन्च्ड माइक्रो प्रोसेसर इन 1971. The first microprocessor which was launched was 4004. Now what this 4004 was? It was a 4-bit microprocessor. But then came 8-bit microprocessors, 8085, which normally is taught in the curriculum. In the market it is obsolete. Nobody uses 8085 nowadays, but still in the curriculum chal raha hai wo. So 8085 is an 8-bit microprocessor. Then with advancement came 16-bit microprocessors like 8086, etc. Then 32-bit, 80186, 286, 386, 486. Then came Pentium. Pentium तो सबको याद होगा, because जब Pentium के PCs आए थे तो बहुत खुश होते थे सब कि हमसे फास्ट हो गया है वो. So what was behind it which made it fast? Can you tell? हम बात कर रहे हैं, हमने शुरू कैसे किया है? 4-bit माइक्रोप्रोसेसर से, फिर हम 8-bit पे आए, फिर हम 16-bit किया, फिर हम 32-bit की बात कर रहे हैं, 64-bit, 128-bit भी आ गया, फास्ट हो रहा है. फास्ट क्या कर रहा है इसको? The data line, the size of the data bit. If I'm saying the first microprocessor which was launched was a 4-bit microprocessor, that means the size of its data bus was 4-bit in size. Then if I'm saying 8085 is an 8-bit microprocessor, the size of the data bus is 8-bit in size. Similarly, size of the data bus is 16-bit and so on. So what is the work of this data bus? The name also specified that the data bus is used to carry the data. If it is a 4-bit microprocessor, it will be able to process 4 bits of data at one time. लेकिन अगर हम उसको 8-bit कर देते हैं तो it will be able to process 8 bits at a time. उसी को अगर हम 16-bit कर देते हैं, it will be able to process 16 bits at a time. अगर हमें 16 bits को एक 8-bit microprocessor से काम कराना था तो उसको 2 cycles लगने थे, but अब एक cycle लगेगा. So the speed has increased, the execution time has decreased. This is my favorite example which I always give to my students, that suppose you go from Chandigarh to Delhi. तो 4 laning होने से या 8 laning होने से क्या फर्क पड़ता है? हम बहुत खुश हो जाते हैं ना 4 laning हो रही है. क्यों खुश होते हैं हम? ट्रैफिक कम हो जाएगा. क्यों? वो क्या ट्रैफिक किस चीज को कम करेगा? जब वो 8 lanes हो जाएंगी लेट से, तो हाउ मेनी कार्स कैन पास एट अ टाइम? 8 कार्स. वही जब 4 lanes थी तो 4 कार्स पास कर सकती थी और बाकी की 4 कार्स उसके पीछे जाएंगी. तो आपका टोटल टाइम फ्रॉम रीचिंग दिल्ली फ्रॉम चंडीगढ़ हैज रिड्यूस्ड. Similarly, as the size of the data bus increases, the total execution time decreases. Fine. This is the significance of the data bus. Now, microprocessor, although it has got capabilities and it was popular also, but still it alone itself cannot work. You need to add certain external peripherals, you need to add certain components to a microprocessor in order to make it a complete functional unit. Can you tell me what are those external components? We need to add input output device. तो देखो आपको यूज करना ही पड़ेगा. We need to add internal ports, because in order to interface with the real world you need to add ports. और ports के लिए हम क्या यूज करते हैं? 8255 chip. That day Chatterjee sir also told in his class ना, जब when you did an example of microprocessor based speed control of DC shunt motor. So 8255 chip is used along with the microprocessor because it does not have any ports of its own. Along with that, or what else is required? Memory. Memory obviously is the very important component. What else? Timers, counters, है ना? Timing delaying के लिए, counting purposes के लिए timer counter you require. Then you require serial port, you require interrupt, etc. etc. So the very significance जो हमने ये बोला था कि हमने CPU को एक चिप में कर दिया, वो थोड़ा सा फर्क पड़ गया है. थोड़ा सा वो significance कम हो गया है, because when you add all these components again, तो वो जो compactness जिसकी वजह से हमारा एक advantage था, वो थोड़ा कम हो गया है. So our design engineers came up with an idea that why not put all these components also on a single chip itself. That is nothing but a microcontroller. This is the main difference between a microprocessor and a microcontroller, that whereas in case of a microprocessor you need to add all these components externally into the microprocessor, which makes the whole system bulky as well as costly. Whereas in case of a microcontroller, all your timers, counters, ports, you need not add any 8255 chip to it, because microcontroller has got its own ports. Then it has got its own timers, counters, it has got interrupts, serial port, etc. all on a single chip itself. So it's like a mini computer. So अगर हम एक layman को समझाना है, who is not an engineer, he just wants to ask me that what is the difference between a microprocessor and a microcontroller, I can tell him that whereas a microprocessor is a CPU on a chip, our microcontroller is a computer on a chip itself. ठीक है? So this is the main difference between a microprocessor and a microcontroller. And this picture, it is depicting whatever I have told. As you can see here, that in this case, this CPU or general purpose microprocessor is a heart, and then you have RAM, ROM, memory, input output ports, that means PPI chip, timers, serial ports, etc. All of these are externally added to this CPU, and that makes it a complete functional unit. Whereas in case of a microcontroller, all these components are embedded on a single chip itself. So apart from compactness, what else is the advantage? Can you tell? एक तो आया आपका एक सब कुछ एक सिंगल चिप में आ गया ना, और क्या एडवांटेज इसकी आपको लगती है? नहीं, डाटा बस हाँ कह सकते हैं, बिकॉज उस केस में हमारे को एक्सटर्नली लाना पड़ रहा था, इस केस में मेमोरी इनसाइड ही है. व्हाट एल्स? स्पीड इंक्रीज हो रही है, और एक इंडस्ट्रियलिस्ट के पॉइंट ऑफ व्यू से सोचो. Just think from an industrialist point of view, who has to make a product 1 lakh units. Maintenance cost. माइक्रोप्रोसेसर की क्या मेंटेनेंस करेंगे आप? But I'm not getting the right answer. I want to hear it. Let us hear from our centers if anyone can answer. स्पीड तो हो गया, स्पीड तो बता दिया, बट एक आंसर है जो मैं सुनना चाहती हूँ. Yes, anyone from RD Engineering College can tell? If anyone is sitting, can anyone tell? No answer. Next. Vijayawada, does anyone have an answer? What do you think is the advantage of microcontroller from the difference which I have told you? Apart from compactness, yes, all of these components have come on a single chip itself. What else can you think is the main advantage? If anyone has any answer, then you can please raise your hand. Okay, someone is coming. Okay. Yes, sir.
Microcontroller point of view, it is much faster compared to the microprocessor.
That is the main thing which I wanted to hear. Very nice. Cost. Cost जो है देखो आपको वो सब कुछ yes sir, thank you, thanks for your answer, that's right. Cost, because you had to externally add all these things. That is why I gave you a hint also, that think of the from the point of view of an industrialist who has to make 1 lakh units. The same thing you can do from a microprocessor, the same function you can do from a microcontroller also, but in this case your cost has reduced. A microcontroller is available in the market for as low as 50 rupees also. आपने तो use किया ना अपने project. Depends upon your application. So cost is another very important answer. Let me see if I have no. Or what else can you think? What else can you think? चलो advantages तो हमने बात कर ली. Speed भी increase होगी, cost is also reduced, and then your compactness is also, of course, power consumption where it is critical. Of course, microcontroller requires less power consumption. But can you think of any advantage of a microprocessor over a microcontroller? Can you think of any advantage of a microprocessor over a microcontroller?
In terms of reliability, maintenance की terms of
आप मेंटेनेंस, आप मैकेनिकल इंजीनियर हैं इसलिए आप मेंटेनेंस की बातें कर रहे हैं. एक चिप में आपको क्या मेंटेनेंस चाहिए?
यहाँ पर एक आइटम भी फेल होगा तो सारा का सारा चिप बेकार होगा. माइक्रोकंट्रोलर
एक आइटम नहीं है वो. आप डोंट थिंक कि उसके अंदर एक सीपीयू रैम रोम ऐसे आइटम खराब हो रहा है. It's a single chip itself. Because of the advancements in VLSI, all of them are crammed together in a single chip itself. It's not like you have to replace RAM, ROM, ऐसा कुछ नहीं है. If you're getting it for 50 rupees, how does it matter? In this case, there is no maintenance, it is only replacement. Can you think of any advantage over centers? Anyone who can answer?
Ma'am, from PVP, ma'am.
Yes.
Ma'am, microcontroller has a limited resources, whereas for microprocessor it has unlimited resources. That is very advantage. And
Yes.
the second one is application-wise, application is not limited for microprocessor, but whereas for microcontroller it is limited. It is specific application.
Yeah, that point I got. So can you please specify more on the first point which you have told, resources, when you say that microprocessor has more resources? In what sense are you telling that resources?
Regarding the hardware integration, suppose I want to add up a new hardware, it can be easily configured, but for whereas a microcontroller it will be a bit difficult.
Very nice, very nice. That's right. Thank you. Actually, what happens is that in case of a microprocessor, you are externally adding all these components. So you have got the, whatever sir has told, I'll name it in another thing. You have got the versatility. आपके पास versatility है, that you can add the amount of RAM, you can add upon the amount of memory, you can add upon the amount of timers, etc. Whereas in case of a microcontrollers, you have everything on a single chip itself. You cannot do anything about it. So you've got versatility. And the second answer also, which his told, is also right, that microcontroller is mainly used for dedicated applications, whereas a microprocessor is used a general purpose. So it also depends upon that which application you are working on. In case it's a dedicated application, for example, your washing machine. Washing machine has to wash the clothes, so it's a dedicated single task. If it's a microwave oven, it's a single task. So in such cases, you will prefer to use a microcontroller over a microprocessor. Whereas in a case wherein it's a general purpose application, वहाँ पे आपको microprocessor जो है वो use होगा. Of course, okay, if I'm saying that amount of memory you are externally adding, है ना, हम यही बात कर रहे हैं ना, but it's not our free will that we can add upon any amount of memory. ये हमारी मर्जी नहीं है कि चलो हम ऐड कर सकते हैं तो कितनी भी मेमोरी ऐड करते हैं. वन थिंग अफेक्ट्स, एक चीज डिसाइड करती है. क्या है वो चीज? एड्रेस लाइन. दो बातें हमने की है, डेटा बस की और एड्रेस बस की. सो वेयर इज द साइज ऑफ द डेटा बस अफेक्ट्स द अमाउंट ऑफ द एग्जीक्यूशन टाइम. जैसे जैसे आपका साइज बढ़ता जाएगा डेटा बस का, द एग्जीक्यूशन स्पीड रिड्यूसेस. सिमिलरली योर एड्रेस बस will determine how much amount of memory you can externally add into it. Okay, can I have the blackboard, please? I want to use the board. So this concept is applicable to both microprocessor as well as microcontroller. It's not that in case of a microcontroller you cannot add upon the memory. You can add, but in that case you will have to sacrifice two of the ports. But now we are discussing that what decides the amount of memory, how much amount of memory can be added to it. That depends upon the size of its address bus. So whereas the data bus determines the speed, the address bus determines the memory. How? Total amount of memory which can be mapped by a microprocessor or a microcontroller is given by 2 raised to power n. हम ऐसे बोलते थे ना कि अभी हमने एडवांस्ड पीसी ले लिया है, इसमें मेमोरी ज्यादा है. इवन योर मोबाइल्स, अर्लियर मोबाइल्स में मेमोरी कम होती थी, नाउ यू कैन ऐड, इसमें 1 GB मेमोरी है. दिस इज व्हाट वी से. व्हाट इज मेकिंग इट, what is deciding it is the size of the address bus. Example, your microprocessor 8085, which is an 8-bit microprocessor, means the size of its data bus is 8-bit in size. The size of its address bus is 16-bit in size. Now, then if it is a 16-bit address bus, the total amount of memory will be 2 raised to power 16. That is 64 kilobytes of memory. Now suppose this size increases. In that case, the total amount of memory will also increase. So that means this is the total limitation. It's not like it's our free will that we can add any amount of memory to it. Okay. Now what is the significance of this address bus? We have already seen data bus is used to carry the data. Address bus क्या होता है कि all your data and the instructions, they are stored in the memory, but they have some address. For example, if I ask you that you go to my house and fetch me something, what is the first question you are going to ask me? Ma'am, tell me your address. That is the thing you are going to ask me. Similarly, when the CPU, your memory, it contains some instructions. When your central processing unit inside the microprocessor, it has to fetch that data which is stored in the memory. Firstly, it will send the address through the address bus. So when you will ask me what is my address, I will tell you. Through that address, you will go to my house and you will bring me that data or whatever. Similarly, the microcontroller or a microprocessor, through the address bus, firstly sends the address. So the address line carries that address, and from that address the particular data or instruction is fetched via the data. So this is the significance of the address. Okay, clear? We have very less time actually. I think 1 hour is very less to tell microcontrollers. But in this class, I'll be telling you just basics because इसके बाद हमने application करना है, तो लेकिन कुछ basics आपको पता होना चाहिए. Microcontroller होता क्या है, इसलिए I'm telling you these basic concepts. These are some applications. That's okay. Okay. A very important question is then how to choose a microcontroller. Now again, Intel in 1980s they launched the first microcontroller, and then with time many other companies they also started manufacturing microcontroller, but Intel gave its permission that yes, you can also manufacture your own microcontroller with the condition that the core will remain the same. The core, हमारा core जो है वो आपका same रहना चाहिए. अब हमें कैसे पता चलेगा हम कौन सा microcontroller use करें? There are so many companies which are available in the market which manufacture microcontrollers, है ना? And you can have a microcontroller for as low as 50 rupees to as high as 4,000 rupees. So in such cases, there are certain criteria which we consider in considering in choosing particular microcontroller. Now let us see these criteria. The first criteria is our computing needs. Computing needs में of course first step is our speed. In such applications wherein the speed is very critical, you need to have such microcontrollers which are fast. जहाँ पे आप कॉम्प्रोमाइज नहीं कर सकते हो स्पीड के साथ में. लेट्स से कुछ ऐसा आपका मैन्युफैक्चरिंग का कुछ ऐसा प्रोसेस है जिसमें इतने माइक्रो सेकेंड्स के बाद ही ये होना चाहिए. वहां पे अगर आपका एक माइक्रो सेकेंड का भी फर्क पड़ गया तो होल बैच will get spoiled. So speed matters. Packaging means that is your final product, does it require that it has to be very compact? So accordingly you will choose such a microcontroller which is comparatively जो आपके ऐसे mounted होते हैं वो ऐसे microcontrollers लोगे आप. ठीक है? Power consumption is another very important point which must be kept into mind. You may have an application in which is a standalone field alone system. You don't have a power supply connected to it. So in that cases, you require that your controller should consume very less power. Then amount of memory, of course, आपका कितना program का size बड़ा है, accordingly you will choose. Suppose you have a very small program, so you need not require very high amount of memory. Input output pins कितनी चाहिए? Input output pins का मतलब है कि how many peripherals you are externally adding to a microcontroller. Because input output pins mainly चाहिए होती है in case you want to have a real world interfacing with the microcontrollers. Timers, upgrade to higher performance means फ्यूचर पॉइंट ऑफ व्यू से भी आपको सोचना है कि क्या इस कंट्रोलर को हम फ्यूचर में अपग्रेडेशन पॉसिबल है, इसकी फ्यूचर वो आएंगे. एंड मोस्ट इंपॉर्टेंट पॉइंट इज द कॉस्ट एज आई टोल्ड यू. कॉस्ट के लिए एक एग्जांपल हम फिर से लेते हैं. सपोज आप एक इंडस्ट्रियलिस्ट हैं और आपने एक टॉय बनाना है. एंड टॉय ने क्या करना है? जंप करना है. इट विल जंप, है ना? एंड आई एम एन एम्बेडेड इंजीनियर. यू कम टू मी एंड यू आस्क मी दैट मैम आई हैव रिक्वायरमेंट that I want to make a toy which jumps like this, but the condition is that the cost should be only 1,000 rupees because the task is not that big, no? It just has to jump itself, है ना? And then you tell me because the cost is important because I have to manufacture 10,000 units. So you tell me that I have given you 1 week time, please make me one product. So I say okay, fine, easy, good enough, I know I'll do this. So when you go, then I am an embedded engineer. I've worked on very hi-fi microcontrollers which have got this feature, that feature, etc. and all. And so I'll think that I want to impress him and I will make a product with that particular microcontroller which has got that feature inbuilt, this, that, high speed and all those things, high memory, highest amount of memory, whereas I don't require that amount of memory. So I go to the market, I purchase a chip which costs me 2,500, high end ले लिया हमने, and I make that particular toy which is working fine. So when after 1 week you come to me and tell me, ma'am, is my product ready? I say, yes, it is ready. See how it is jumping, and you also very happy. Oh, my product is there. Then you say, okay, I want to give an order for 10,000 units. But then suddenly I remember that you had told me something about the cost, and I tell you, no, see, the microcontroller only costs 2,500 rupees, and considering my work also, this will be 4,000 rupees, whereas your budget was 1,000 rupees. So imagine you have to make 10,000 such units. Cost is so important. In every application, whichever application you're making, you have to see that is the cost critical. Accordingly, you will choose a microcontroller. As I told you, you can get it for as low as 40 rupees to as high as 4,000 rupees also. Apart from the computing needs, again, you have software development tools. Software development tools, because what happens is that one is the hardware part. You make the hardware connections, but you have to program it also, na? So do you have the required software development tools? Yesterday, Baban sir was telling you about pick microcontroller, and then he was telling that these are the software development tools. So you should see that are those software development tools available to you? Then of course the final one is the availability and source. because it happens many times that during your development of the product it may get damaged. So is it readily available in the market, or in future also in case you want to change it, is it easily available in the market? So these are some of the points which you must keep in mind while deciding which type of microcontroller you have to choose. Then these are some of the companies which are producing 8051. And this is the block diagram of the original microcontroller which was introduced by Intel in 1981. In every microcontroller you will have this only, with the additional features. So as you can see here, this is the CPU. It is the brain of the microcontroller because it's all where your processing takes place. Then this is the bus control, the control unit. Then there are 4 input output ports. You need not connect any 8255 PPI chip to it. It has got 4 ports of its own. Then for serial port interfacing, you have one serial port. Okay? And there are 2 timers, timer 0 and timer 1. On chip RAM, the basic 8051 has got 128 bytes of memory RAM. On chip ROM, these are 4 kilobytes, but they can go up to 64 kilobytes. That I've already told you how it can go up to 64 kilobytes, because it has got 16 bit of address bus. But original 8051 has got on chip 4 kilobytes of ROM. Then there is interrupt control, and this oscillator circuit here, it is the heart of a microcontroller. We all need heartbeats for living. Similarly, microcontroller needs pulses, and that is generated by this oscillator circuit. And also those pulses means the frequency of the operation of a microcontroller is decided by this quartz crystal which I have connected here. This is a quartz crystal. Suppose, and this is another important difference between a microprocessor and a microcontroller, that whereas in case of a microprocessor, whatever amount of frequency you want to work with, it will internally divide it by 2. For example, आपको अगर 3 मेगाहर्ट्ज पे काम करना है तो आपको उस पे 6 मेगाहर्ट्ज का फ्रीक्वेंसी क्रिस्टल देना पड़ेगा, सो ऑटोमेटिकली उसको हाफ से डिवाइड करेगा. वेयर एज इन केस ऑफ अ माइक्रोकंट्रोलर, जितनी फ्रीक्वेंसी पे आपने उसको काम करवाना है उतनी ही फ्रीक्वेंसी पे आप जो है उसका क्रिस्टल लगाएंगे. Now, whereas a microcontroller can work from a frequency range of 4 megahertz to 30 megahertz. जिसकी frequency range होती है ना, that ranges from 4 megahertz to 30 megahertz, but the most widely used frequency is 11.0592 megahertz. ये थोड़ी typical सा figure है, 11.0592 megahertz. Can you tell me why this particular frequency is required? आप में से कोई बता सकते हैं? Those who have worked on microcontroller, of course, they will be aware of. Let us ask from our centers if anyone is aware of. If someone wants to answer, please raise your hand. Yes, anyone? Does anyone know why this particular frequency 11.0592 megahertz is to be used with a microcontroller? If you have an answer, you raise your hand. Yes, we have an answer from Vijayawada. Yes, sir. So please turn on your mic.
Yeah, for having this baud rate, ma'am.
Baud rate, yes. Yeah. Can you elaborate?
For serial communication.
Yeah, can you elaborate on this?
There's to synchronize all the operations related to various devices, that is the maximum speed that it can be operated with.
That's true. Right.
For having proper establishment of connections, it is used.
Very good. Very good. We are getting some very good answers from Vijayawada. I think there was some answer from Maharashtra also, Government Polytechnic. From Government Polytechnic, Bid, Maharashtra. Yeah, they have also given the right answer, that for serial communication. That's also right. See, whenever you want to do serial communication with the IBM PCs, you need to have baud rate compatibility. Baud rate compatibility is very important. And at this particular frequency, 11.0592 megahertz, the baud rate compatibility of 8051 with the IBM PC is the best one. So that is why this particular frequency is used. Okay, so that was about oscillator circuit. And what else can I do tell you? Okay, I'll tell you the pin diagram. Hmm. Now, another thing which you must be aware of is the pin diagram of 8051, because whenever you have to work on any microcontroller, you need to be well conversant with the hardware and the software. So if we talk of the hardware, you need to know that what are the various pins wherein you have to connect your devices. For example, you want to connect your LCD, you want to connect your switches, you want to connect your LEDs or any sensor, output input device. You need to know all the pin connections. So this is 40 pin IC, as you can see from here. And from the notch, ये notch दिख रहा है ना आपको, ये वाला, this notch. So this tells on the left side of this notch is pin number 1, and on the right side of this notch is pin number 40. Keel, if we have a keel here, check. And as you can see from here that on left side, on from pin number 1 to 8, you have port P1. There are 4 ports basically, as I told you: P0, P1, P2 and P3 for the real world interfacing. And on the right side we have port 0, on the left side this is port 0, this is port 0, this is port 1, this is port 2 and this is port 3. 0, 1, 2 and 3. Now can you make out any difference among all the ports? There is only one port which is dedicated input output port. बाकी सभी ports के side में in the brackets you are getting some dual function. See, in this port P1, P0 also, this is the port, and in the bracket you have AD0 to AD7. In this port 2, you have port 2 pins as well as higher order address lines. On the port P3, you have the port pin P3 as well as your control lines. But P1 is the only port which has got dedicated input output. So we prefer to use this port in because it is a dedicated port. And coming back to this, there is another advantage of a microcontroller or microprocessor, that in this case you have single bit addressability. As you can see from here, pin number 1, it's written P1.0. What does it mean? P1.1, 1.2 से लेकर P1.7. There are total 8 pins, na? In every port there are 8 pins. So there are total 4 multiplied by 8, that is 32 input output pins. So in this case you have single bit also. अगर हमने किसी एक पर्टिकुलर सिंगल बिट को चेंज करना है, वो भी हम माइक्रो कंट्रोलर के केस में कर सकते हैं, बट इन केस ऑफ अ माइक्रो प्रोसेसर देयर इज नो सच ऑप्शन. उसमें आपको पूरे के पूरे बाइट पे वर्क करना पड़ेगा, बट इन दिस केस यू कैन वर्क ऑन अ सिंगल बिट itself also. So as I told you, P1.0 से लेके 1.7 है. और इसके बाद में on pin number 9 we have a reset circuit, another very important, I'll tell you after this reset circuit. And pin number 10 to pin number 17, as you can see from here, we have port 3 with dual function of these are all the control lines. And on pin number 18 and 19, this is where that crystal circuit is to be connected. As I told you, that is the heart of the circuit, heart of your whole microcontroller system in which the pulses are generated. So that is connected on pin number 18 and 19. And on pin number 20, it is ground. Pin number 40, it is VCC. So microcontroller works on plus 5 volt DC. It only knows the logic of 1 and 0. So if I'm saying a logic of 1 means VCC, if I'm saying a logic of 0, it means a ground. The first thing which you must test when you're working on any microcontroller is that the pin number 20 and pin number 40 should not be short. VCC और ground short नहीं होना चाहिए, ये आपको सबसे पहले चेक करना है. उसके बाद आपका pin number 21 to 28, you have port P2. Along with that, you have higher order address lines. And on pin number 32 to pin number 39, you have port 0, along with that lower order address and data lines which are multiplexed. Now if you have worked on microprocessor, you must be knowing about this multiplexing of the address and data lines. So it's an 8-bit data line, data bus and 16-bit address bus. So lower order address bus जो है आपकी 8 address lines हैं जो आपकी A0 से लेके A7 तक, they are multiplexed with the data lines. So that is why we have this term AD0 to AD7. And the higher order address lines A8 to A15, they are dual function of the port P2. Now ये जो multiplexed होती है ना lower order address and data lines, इनको रियल टाइम में जब हमने काम करना है, जब जो हमारा साइकिल रहेगा उसमें डीमल्टीप्लेक्स करने के लिए वी हैव दिस पिन नंबर 30, दैट इज ALE, एड्रेस लैच एनेबल. This is used to demultiplex address and data lines. And on pin number 29 you have this program store enable. Program store enable का मतलब क्या होता है कि as I told you, microcontroller has got inbuilt ROM, उसमें inbuilt memory है. But sometimes it may happen that you may require additional memory. You can add. Similarly, as in this pin diagram also you can see 8051 के नीचे क्या लिखा है 8031. So 8031 is basically a microcontroller which does not have a ROM. It's a ROM-less microcontroller. So in such cases you need to externally add the memory to it. In those cases this pin number 29 will be grounded, PSEN. Similarly, pin number 31, that is external access pin, this will also be grounded in case you are externally connecting the memory. But one thing you must keep in mind, now you may ask me ki pin number 29 is also used for ground and in case external memory, and pin number 31 is also used as a for grounding in case external memory, then what is the difference? The difference you must keep in mind is that you can leave the PSEN unconnected in case you are not using any external memory. तब आपको इसको ground देने की जरूरत नहीं है, आप इसको unconnect छोड़ दो. But pin number 31, in case you are not using any external memory, you cannot leave it unconnected. You have to connect it to VCC. This is a practical thing which you must keep in mind whenever you are working on a microcontroller. अगर आपने अपना, you make your whole circuit, you make your whole program is working fine and everything, but if you leave your pin number 31 unconnected, your microcontroller will not work. Clear? So this is basically the crystal connection I was telling you, pin number 18 and 19. You have this quartz crystal here and there are two these capacitors. This makes a complete resonant circuit which is required for generating the pulses required for the synchronization of the microcontroller. Then apart from that, as I was telling you, there is another circuit which is also important, that is reset circuit. One is a crystal circuit which we have already discussed on pin number 18 and 19. On pin number 9, we have this reset circuit. It is also very important. What happens is that whenever you want to make a reset, all the internal operations of the microcontroller, they are reset. All internal registers, they are zero. They are zero. So how do you do that? It is on pin number 9, and as we can see here, we have a capacitance, 10 microfarad capacitance, which is connected to this VCC, and there is one current limiting resistor 8.2K which is connected to this ground. So whenever we want to give a reset to this, we simply give this VCC through this capacitor. When this capacitor is charged, this VCC is connected to the pin number 9. This is how we give it a reset. We have one capacitor, 10 microfarad capacitor, and we give this VCC, this gets charged, and then this is connected to the VCC is connected to our pin number 9, that is the reset. But the disadvantage of this kind of circuit, isko hum bolte hain power on reset, because whenever you want to give it a reset, what you have to do is you have to switch it off, again give it on, that way VCC will be connected, but that way the other operations are also affected. So what we prefer is another circuit in which we have used a debounce, a switch here. So whenever we want to give it a reset, we simply press this switch and then this VCC is connected to this reset. So this is known as power on reset with debounce. So as you can see, this complete circuit This complete circuit is basically the basic connections you must make. Whether you are making a small project, whether you are making an LED glow, or you are making a rocket science. At least this much of connection must be made. What are those? One is your crystal circuit, 18 and 19. One is your reset circuit, and as you can see from here, pin number 31 is connected to VCC. So if you forget to connect this pin number 31 to VCC, your whole circuit will not work. So whenever you work on any microcontroller based project, you must firstly make this circuit. Yes.
What is the difference between virtual ground and normal ground?
किसके केस में?
Difference between virtual ground and
कौन से सेंटर से एक मिनट बात करें?
Bhara
Bhara University, sir, we have got a question from you. What is the difference between a virtual ground and a normal ground? In which context are you asking this?
Hello.
Yes, sir.
Ma'am, I'm just asking that what is the difference between a virtual ground and normal ground? There is not any contest, but say suppose we are grounding our microcontroller, or you can say we are earthing our microcontroller.
Yes.
So, is there any difference that we are doing it virtually or
No.
through the...
No. Yeah, I'll tell you. See, in this case, on pin number 40, as I told you, we are connecting plus 5 volt DC supply. And on pin number 20, we are giving it 0 volt. So that 0 volt is not actually 0 volt. There is a limit. I mean, there is some voltage, but it is very low, almost near to 0 volt. So that is actually through the power supply that we connected. It's not virtual grounding. It is through the power supply that we are giving it a plus 5 volt at our what do you call it, VCC pin number 40, and on pin number 20 you are giving it a ground proper. It's not a virtual ground.
Okay, okay, ma'am. Thank you very much, ma'am.
Okay. Any other questions? Yeah. Now we were talking about the basic circuit. See, as I told you that one thing is that you need to make the your what do you call it, crystal circuit. You need to make this reset circuit, and you need to connect this pin number 31. One more thing which you must do is you must conduct 2 tests first. I'm talking of practical things which you must do whenever you work on a microcontroller. You must do 2 tests. One is your crystal test. What is the crystal test? See, as I told you that microcontroller has to work on some frequency which this crystal is generating. But how do we know it is actually generating it or not? Because if it is not actually generating the right amount of frequency and the right amount of pulses, your microcontroller will not work fine. So we have to conduct this crystal test. What we do is we take our oscilloscope, we connect it on pin number, or I'll show you this this pin number 30. Pin number 30 ALE. We connect it here. If you are getting 1/6 of the frequency here, that means the frequency crystal circuit is working fine. This is a practical thing I'm telling. You will not get all these things in the book. So for example, if I'm talking of 11.0592 megahertz, let's say close to 12, then आप टेस्ट करना चाहते हैं, जब आपने इसको ग्राउंड दे दिया, जब आपने इसको VCC दे दिया, आप अपनी पिन नंबर 31 पे जाके अपना ऑसिलोस्कोप लगाएंगे और वहां पे आपने चेक करना है कि वहां पे आपको पल्सेस मिल रही हैं कि नहीं मिल रही हैं. 1/6 फ्रीक्वेंसी मींस ऑलमोस्ट क्लोज टू 2 मेगाहर्ट्ज के आपके पास फ्रीक्वेंसी जो है वो आनी चाहिए. And on pin number 18 also you can check there, and you will see that you are getting those pulses, square pulses of the required frequency. But आपने पिन नंबर 30 पर भी लगाकर देखना, ALE पे भी आपको 1/6 फ्रीक्वेंसी मिलना चाहिए. The second test which you have to perform is a reset test. Reset test का मतलब क्या है? That on applying this reset circuit, you will take one multimeter. एक उसका जो ग्राउंड है वो तो आप पिन नंबर 20 पे लगाएंगे, and the second connection you will check each and every pin. You will check each and every pin. Now, before doing that, I will tell you one concept. That as we have seen, there are total of 4 ports. Port 0, port 1, port 2 and port 3. Port 0 is the only port in case of microcontroller which is an open drain. What is the meaning of open drain? that it does not have internal pull-up resistors. All the other ports, port 1, port 2 and port 3 have got internal pull-up resistors which connect it to VCC. Now if these pull-up resistors are connected it to VCC, that means if you are connecting multimeter to your all the port pins, what should be the status there? What should be the status there? You can write the answer in case somebody wants to answer. My question is that because I'm saying only except port 0, the rest of the ports P1, P2 and P3, they have got internal pull-up resistors which is connecting it to VCC. So suppose after giving it the power supply and on checking the reset circuit, I connect a multimeter. One wire I connect to the ground, the other wire I connected to the VCC, sorry, all port pins, and I check the status of the port pin. What should I get in the multimeter? Yes, answers. Anybody can answer? Somebody wants to answer about this? You can write also. अच्छा, आप में से कोई?
Ma'am, can you repeat the question, please?
Yeah, my question is that I'm saying all the 4 ports of P0 only except port 0, other ports have got internal pull-up resistors which pull it up to VCC.
Yes,
So suppose I am doing the reset test and I have made all the connections, I've given it the power supply also. Now taking the multimeter, putting one pin on the ground, I am testing on all port pins except port 0. What value should I get on the multimeter on all the ports?
5 volts.
5 volts. Naturally, it should be 5 volts because you've given yes sir, thank you. Because VCC is what? It is nothing but 5 volts. All the ports except port 0 have got those internal pull-up resistors which will connect it to port high VCC. But if you check the status of port 0, it will have something like 1.2, 1.3, etc. such kind of port pins because it does not have all that port pin internal pull-up resistor. So if you are getting such status, that means your microcontroller is working fine. So this is known as reset circuit. रीसेट सर्किट में आप क्या अच्छा अब यूज करना है, सपोज आप पोर्ट 0 को यूज करना चाहते हैं तो हम क्या करते हैं उसमें हम एक्सटर्नल पुल अप रेजिस्टर्स लगाते हैं. ऑलवेज रिमेंबर दिस, whenever you're working on a microcontroller and you want to use port 0 for your project, you need to externally connect external pull-up resistors like this. 10K के external pull-up resistors लगाने पड़ते हैं because it's an open drain. अगर आप ये pull-up resistors नहीं लगाते हो और आप अपना port 0 को use कर लेते हो, your circuit will not work. So these are some of the basic things which I'm telling you that when you're working on any microcontroller, you must be aware. ठीक है? This was all I could tell in 1 hour. About, I'll just tell like that. I don't need this presentation now. I'll just discuss some more things about when you have to make a project. See, we have talked about hardware. Of course, सारा तो हम नहीं discuss कर सकते, but still we have discussed some basics about a microcontroller, basics things which you must keep in mind when you are working on a microcontroller. Now we come to the software part. Software part is that you have made your circuit, everything, you have made your connections, but you have to write something to the controller. Microcontroller does not understand anything else other than 0 and 1. Logic 0 and 1 only it understands. And that is known as machine language. But writing a program in machine language is very cumbersome. Earlier, programmers, when they had no choice, they used to write the program in machine language. That used to get burnt into the controller. But because it's very cumbersome, in order to troubleshoot also it's very difficult. So what happened is that programmers came up with the assembly language. What is assembly language? Assembly language makes use of English-like words which are known as mnemonics. For example, move, add, jump, sub, add, etc., etc. So you write your program in assembly language, but again you cannot burn your program in a assembly your program written in assembly language into the controller. So what you do is you convert it into the hex file. हेक्स फाइल इज नथिंग बट योर मशीन लैंग्वेज यूजिंग एन असेंबलर, ठीक है। सो आप उसको असेंबलर से कन्वर्ट करते हैं हेक्स फाइल से, एंड दैट यू बर्न इनटू द कंट्रोलर। हाउ यू बर्न, अब मैं इसके बाद में आपको बताऊंगी। लेट मी फर्स्टली फिनिश द प्रोग्रामिंग लैंग्वेजेस। But though the things became very simple because this is a language, English like words which we understand, we can write it also. But the disadvantage of assembly language is that it is machine specific. Suppose I have one microcontroller, it will have its own machine language. I want to work on some other microcontroller, I will have to learn its machine language. So I'll keep on doing this only. Instead, programmers came up with a high level language which is advantage over our assembly language is that it is portable. You write your program for one microcontroller, will work for the will work for third and on. So it is portability. And the most widely used high level language for 8051 in the market is C language. C language में सबसे ज़्यादा जो है वो popular है. One advantage of C language is it is simple, short, whereas you had to write 4 or 5 instruction in assembly language, you have to write only a single instruction in your C language. Of course, the biggest advantage is the portability. You can write your program for one microcontroller, the same program will work for others also. And then there are some defined libraries built inside the C which you can use as such for writing your program. Still, there are some people who prefer to use assembly language over C language. Can anyone tell me? Can anyone tell me, is there any advantage of assembly language over C language?
Debugging.
Debugging तो सर C language की ज़्यादा simple है comparatively. और yes sir.
Ma'am, using assembly language, the code may be a bit tough to code, but it executes much faster, ma'am. Compared to your C, it requires additionally runtime and a compilation and all. But whereas for assembly, once it is a hex code, it will be much faster to execute.
Yes. Any other advantage? Let us see Government Polytechnic Bid. Yes, sir. Thank you for your answer. That's correct. Because in case of in case of assembly language, in case of a C language, that is one of the part. Firstly, it converts it into assembly and then in the C. So execution is faster in case of assembly language. Any other advantage from Government Polytechnic Bid Maharashtra? Can anyone tell? Or anyone? You see, in case of a microcontroller, your on-chip memory is limited. So the size of the hex file which you create is very important. आपका जो program का size है वो तो no doubt we have seen that the size of the main program of a C is shorter as compared to your hex file. But the hex file size of assembly language is shorter as compared to C. This is another advantage of assembly language over C language. So you have written your program either in assembly language or in C language. Assembly language में आप उसको assembler के through convert कर देते हो, and in case of a C language you require a compiler. For example, Keel compiler is the most widely used, which is used for converting your program from machine language to C language to the machine language or a hex file. Create कर दिया hex file. What next? Burning your hex file into the microcontroller. Now there are two ways. One is known as in-system programming. In case of in-system programming, you need not take out your chip outside. You simply connect your circuit into your PC. You program it, burn it into your controller. Within few seconds, it erases the program, older one, and it rewrites. Second option is using a universal programmer. Universal programmer, for example, UniPro, SuperPro. These are separate hardwares wherein you put your chip and then you connect it to the PC. They have got their own software. Then you burn it and then you run it. इससे पहले आजकल तो I don't know if anyone uses this, but there used to be some microcontrollers, for example 8751 series microcontrollers, which had got UV programmability. Because हमारी जो memory है ना इसमें EEPROM, Why we are able to do it so fast? Electrically erasable है ये. Electrically erasable होने से क्या हो रहा है कि आप उसको कमांड दे रहे हो, वो immediately erase होके दोबारा प्रोग्राम भी कर रहा है. पहले टाइम में एक और तरह के माइक्रो कंट्रोलर्स आते थे 8751 सीरीज के, उनमें क्या होता था, आपका क्या कहते हैं, विंडो होती थी एक. So you used to take out your controller, put it into that burner, and that burner used to put UV rays into it, and those UV rays then erase the old program. उसको around 30 minutes लगते थे, wait करते थे, and then you used to put. Now that is not the case, but that is another way of programming it. So these were all the basics. Now I wanted to interact with the center. Does anyone have any doubts? Because we have come to the end of this session. In the next session, after the tea break, then we'll be seeing some applications based on microcontrollers. One robotic arm robot one of our students has made. So he'll be demonstrating you that. In case anyone has any doubts, you want to discuss something. Center से connect करवा दो. I think Vijayawada they are saying something.
One more
Yes,
thing
sir.
to add up. One more thing to add up regarding UV ma'am.
Yes.
Regarding EEPROM, if you try to erase the content, it will erase the content totally from the memory. But whereas using UV you can even partially delete the content from the memory and reprogram it. That is the major advantage of UV. Only part of the content can also be updated or modified using UV. But whereas for EEPROM, it is not possible like that. That is the major advantage, man.
Okay.
As
So
far
what? Okay. So what sir is saying is that parts of memory also you can erase using the UV prompt. That is one advantage. Selectively, you want to select that only this much amount of memory, but that is, I think, it's possible in case of flash programming also. You can selectively choose a particular. It's not only, sir. It's not only with the UV prompt. That is possible with your with your flash memory also.
that is the flash RAM that you are coming in recent days, ma'am.
Yes.
But
That's
whereas
what
UV
I'm.
it is in the previous technology, ma'am. So at this stage also they are able to do that.
Yeah.
Flash memory in recent days we are hearing about flash RAM, right?
Yeah. Flash RAM in that case also this is possible. Right.
That's what I mean, ma'am. Flash RAM it is possible, but the technology is a recent one, or maybe some 10 years ahead. But UV prom is a old one.
That is
Compare
an old one. That is what I'm saying. The earlier, around 10 years back, I had also used UV Prom only.
That's what, man. So 10 years back itself, UV prom has gained its significance only because part of the memory can be erased.
Yes, that's true. Thank you. Anything else? Other centers से भी एक बार बात करा दीजिए. In case anyone wants to say something, then we can proceed for the tea break. Anyone from Vakna Ghat? Vakna Ghat, last.
Oh,
Sir, any
hello.
doubts? Any doubts?
Ma'am, can you explain us the difference between 89C51 and 89S51?
So that depends upon the static memory and the type of memory actually. That is a static memory, types of memories.
Okay, ma'am. So, which from
both-
both of these, which one we can use for in-system programmable?
C is basically is used for the CMOS technology. तो जो
Yes, ma'am.
टेक्नोलॉजी उसको मेमोरी को बनाने में लगाई गई है वो उसके लिए सी रिप्रेजेंट करते हैं, एस यूज फॉर स्टैटिक. But much details I cannot comment on because that is VLSI people can better tell you about the technology behind the making of the memory. That I cannot tell in much. But C stands for CMOS and S is the static memory.
Okay, so ma'am, which chip we can use for in-system programmable?
C is mostly used.
C, 89C51.
And C5.
Thank you very much, ma'am.
Okay. Any other doubts? Any center? Government Polytechnic Beed Maharashtra, any doubts you have? No, then please say no. No doubt. Okay. Okay. Yes, sir. Tripathi, sir. Any doubts? MMU Mulana?
Yeah, thank you very much, ma'am. Thank you very much. It's good lecture. Good lecture. Right.
Thank you. RD Engineering College. RD Engineering College. Yes, sir.
Hello, ma'am. No
Yes.
doubt, ma'am.
Okay.
Thank you very
Thank you
much.
so
Thank you
much.
very much, ma'am.
Thank you. Now we can proceed for our tea break. And yes, another, I want to make an announcement to all the centers that we will be doing the validation at 12:30. At 12:30, we'll starting with the validation. So,
Right. We will be ready. We will be ready.
okay. So after
Yeah.
15
Right.
minutes, we'll again come here and we'll begin with our next session. Okay, we go for a tea break now. Thank you so much.
Sure.
लैपटॉप करो बिकॉज अपना करो So welcome back all of you. Last session of our 5 days journey into the insight of industrial automation. We have with us Mr. Alok Deep. He's our ME Instrumentation and Control student. He is going to discuss intelligent control of robotic arms. Because if we talk of industries, robot is a very indispensable part. He has designed this robot on his own, and he'll be telling you about all the things about what this robotic arm is going to do. He's made use of Arduino microcontroller for this. And Alok,
Thank you. Good morning to all. I'm going to discuss intelligent control of robotic arm, and these are the main contents of my presentation. Ma'am, this slide. These are the main contents of my PPT. Introduction. At first, we have to know what are the main applications of the industrial robot. In this slide, you have seen that the drilling, welding, painting, pick and place, cutting, assembling the car, assembling the ICs. These are the main applications of the industrial robot. I am focusing on the robotic arm, which is my thesis topic also. At first, we can design and simulate the robotic arm on the in the MATLAB and Robo Analyzer software also. Simulation is necessary because we have simulate this thing before making the hardware project. If we make the hardware project and it not work properly, then the loss of the money and the time are there. So we have to simulate the robotic arm in the simulation software. It is also in the MATLAB. We have to add on the robotic toolbox in the MATLAB, and this is the simulation procedure there. The starting window is, this is the starting window. RTB demo, we have to write the RTB demo in the MATLAB command window. Before you have to install the RTB tool, which is designed by the Peter Cork, the scientist, the professor in the Australia, Queensland University. This is the simulation of the 2 degree of freedom robotic arm in the MATLAB. And we can also simulate the robotic arm in the Robo Analyzer software. The Robo Analyzer software is designed by the Professor S.K. Shah of IIT Delhi. We can simulate many of the industrial robots like ABB, KUKA, and other also. And we simulate and check how it will work before making the hardware. We can check the joint angle, joint torque, and transformation matrix, inverse kinematics, forward kinematics of the robot in the simulation. Simulation in the MATLAB and simulation in the Robo Analyzer. I have a video of the simulation in the MATLAB. This is a simulation of the robotic arm in the MATLAB. And simulation of the robotic arm in the Robo Analyzer is before going to the PPT. I want to show a small video. What are the applications of the robot in the industries? volume come. First is the arc welding. Spot welding. Machine tending. Painting. Picking and placing. Assembly. Cutting. Gluing. These are many applications of the robotic arm. Now I am taking the example and making a prototype of the robotic arm for the pick and place and cutting and drilling operation. This is the robot here, and components I used here is the Arduino Uno board, DC motor, L293 motor driver IC, ultrasonic sensor, and servo motor. This is a connection diagram of the robot arm. The Arduino Uno is the brain behind this robot. It gives the command to the motors, servo motors, and ultrasonic sensor takes the signal of the object, the distance in the centimeter, and take the action what it has to done to with the this prototype. Now now this is the arm motor 1, arm motor 2, and drilling motor. This is the L293 motor driver IC, Arduino Uno board. Ultrasonic sensor is connected to the pin number 2 and pin number 3. Servo motor connected to the pin number 4, 5, and cutting servo is connected to the pin number 7. I use here L293 motor driver IC because microcontroller signals are 5 volt DC signal, and it is not able to run the high voltage motor. So we use the motor driver IC, L293 motor driver IC, by which we can run 2 motors bi-direction, and we use here the 9 volt voltage for the motor and 5 volt signal from the Arduino Uno board, which is a signal voltage. It controls the direction of the motor here. This is a complete hardware of my project. Now I want to show the video of cutting and drilling operation and autonomous mode. This robot work on 2 modes, autonomous mode and cutting mode. Cutting mode, in the cutting mode we can cut or drill any object according to the programming, how much it is close to the driller. The cutting and drilling application. As you see in the, this is the wood. When we place the wood near to the driller is start here. I code in the programming the 5 centimeter distance from the object, then it will start. We can change this coding or the distance. And now in autonomous mode. It will move according to the signal given by the microcontroller, which are coded, and the movement of the DC motors, servo motors are according to the code. Now I want to explain the circuit diagram in the detail now. Here the 2 pins are connected of the ultrasonic sensor on the digital output pins of the Arduino board, and it takes the signal and it processes according to the code in the microcontroller Arduino, and then it gives the output to the serial monitor of the IDE of the Arduino. Servo motor, the control signal of the servo motor are given to the orange wire of the servo motor, and it moves according to the control signals to the Arduino. And VCC is the 5 volt voltage to the servo motor, and this is the ground one. Same here and same here also. Now L293 motor driver IC. The signal pins are 1A and 2A is connected to the pin number 8 and pin number 9. As we give the signal high, low, low, high, 5 volt, 0 volt, according to this, if the signal is 5 volt and 0 volt at pin number 9 and 8, motor moves clockwise, and 0 volt and 5 volt, if the signal is reverse, it moves in the anti-clockwise direction in the R motor 1. In the R motor 2, the signal voltage RA0 and RA1 is connected to the pin number 11 and pin number 10. As the code in the Arduino microcontroller, it controls the motor R motor 2 high, low, low, high sequence, and motor 2 is run according to the sequence. Drilling motor is work as a ultrasonic sensor receives the signal, the object is within the 5 centimeter or not. If it is less than 5 centimeter, it start drilling. This is a complete working of the project. Now I want to run the hardware project. Now ma'am, focus on the hardware. चला देंगे। अभी डाउट भी तो होंगे ना, डाउट भी पूछेंगे लोग सर्किट डायग्राम का, उसमें डिस्कस करने में टाइम लगेगा। हो जाएगा सर, हो जाएगा। Presently it is working in the autonomous mode. Because the autonomous running code is burned in the microcontroller, so we need not to connect the Arduino with the computer. If we want to change the code of the robot, then we have to connect it with the laptop and change according to the Now I want to change the code of the robot. Switch off the power supply. Connect the USB jack to the robot Arduino. This is the Arduino IDE as you see in the screen. Now we have to change the code, then we have to burn this code in the microcontroller of the Arduino. Now click on the execute button here. Cursor, please show the cursor here. Up, side में. Cursor, up थोड़ा सा up करना. अच्छा zoom. Windows cursor. This is the execute button where the cursor is there. Now I am clicking this. Now it shows the done uploading. Now program, code is burned in the microcontroller, and when we place the object here, then this motor start running, the drilling motor. Object ultrasonic sensor senses the object. It is less than 5 centimeter, then motor is start running. Now going to the PPT again. From the centers, if you have any doubt regarding the circuit diagram, because many persons have the confusion in the circuit, they can ask why we use this and the working of the circuit.
Dear, good morning, Akhilesh Tripathi from Mulana.
Good morning, sir.
Dear, can you suggest me some forward kinematics of this your robot card?
Actually, sir, I have to implement the forward kinematics in my thesis topic, but presently I have only arranging the motor's actions here. Forward kinematics is by we giving the joint angle to the robot and get the values in the x and y. It is the forward kinematics for the robot arm.
Yeah.
And inverse kinematics, we give the values of x and y of the, suppose that this is the robot and this is the end effector is there. End effector, and end effector's position is x and y coordinates. Suppose x and y. if we get the values, the x theta in the values of the x and y, it called the inverse kinematics. And if we get the values in the value of x and y in the theta 1 theta 2, which is a joint angle with respect to other joint, means theta 1 joint for the joint 1 and theta 2 for the joint 2, then it is called forward kinematics, means value of x and y we have to find forward kinematics. And in the inverse kinematics, we have to find the joint angles theta 1 and theta 2, sir.
How many links you have considered with this?
Sir, presently in this robot, I have considered only 2 links, sir. It is prototype model. College has going to purchase a 5 degree of freedom robot, which I will show in the next STC. This is the only prototype model, sir.
But sir, only 2 links you have taken, eh?
Yes, sir. Only 2 links. One link is there. This is one, and this is second link.
What is the joint position?
Joint position means angle.
No. Joints you have taken.
Yeah.
Which motor you want to fit over, or it is fitted over here? Servo motors?
Servo motor I use here for the cutting prototype purpose. This is the servo motor blue one.
Add joint number 1 between link number 1 and 2.
Between link number 1 and 2, this is the DC motor, sir. DC motor 1, and this is the DC motor 2. Okay, sir.
What's the rating?
Rating is the 12 volt and 50 to 100 milliampere.
200 milliamps, huh?
50 to 100 milliamps.
Okay, so all DH parameters and all you will calculate afterwards only, huh?
Actually, sir, yes, because we have the software now, and we simulate, and DH parameters are also automatically calculated here, but as we change the position in the simulation.
Yeah, can I discuss with you separately? I will take the time from you.
Yes, sir.
And to calculate DH parameters or inverse kinematics and all.
Sir, I am working. Right. I am working on this, and this is also my thesis topic is there, and under Lini ma'am, and we can discuss anytime, sir.
What's the target? What's the target?
Target of which, ma'am? Which, sir?
Target of this? Yeah, thesis.
My thesis. Okay, I am designing a pick and place robot, and identifying the defect in the subject, and if the subject is defective, then pick the subject and place at the another position. If it is good, then it have to pass.
You want to what else parameters you want to consider? Either accuracy or timing or distance. What else parameters you want to discuss with this?
No, sir. My only objective is to pick that object which is defective and place to the other position in the box or any something other thing.
You want to compare some parameters along with some standard robot.
For example, suppose a biscuit, it is round shape. If it is any defect in there, it is broken, then it's compared with the another the predefined biscuit which is in the round shape, and it compares, and if it is not matching the standard one, then it will take and place in the other place.
Dear, my question is, any parameters which you want to consider or which you want to compare with the other parameters of some other robot? Any parameters you are going to consider?
Some other robot? No, sir. Presently, I am not comparing with some other robot. Presently, I am creating my own. Then I will compare with the standard one.
Are you taking any help from this robo analyzer which has been developed by Dr. Saha, IIT Delhi?
Yeah, sir. In the robo analyzer software, the simulation, the 3D modeling is very good, and many of the industrial like ABB and KUKA robots, many of the robots simulation is predefined in that software, and you can use. It is very simple, and you need not have to install that software. Only exe file is there. You have to execute it. And it is free of cost on net.
I know, I know. But a KUKA robot, they're not going to use this one robo analyzer.
KUKA robot, where we
Yeah.
use? It is
No,
in the
no, but see, but it is not built with them. This robo analyzer software, it is not there with the KUKA robot.
no sir. In the options you have to check. You have to check when we click your other options in the left corner downside. Then you when you click on that option, you have the many name of the industrial robots. Then you have to choose the KUKA one or the
I,
Puma 560.
I know, I know, I know.
Yeah.
ठीक है dear. Thank you.
Okay, sir.
Good
Okay,
day.
sir. Very, very thank you, sir.
Good. Right. See you. Near, can you provide me your contact number?
Yes, sir.
Yeah.
Please note down, sir.
Yeah.
God file में लिखो. क्लियर और कोई नोट करना हो तो नोट कर लेंगे और भी. हाँ, मैं नोट कर देता हूँ. बड़ा सर.
आ जाओ. काम तो चलेंगे सर, ये भी काम ही है सर आपका.
बहुत बड़े काम दे रखे हैं आज तक.
अच्छा, क्या क्या?
You can note down the contact details. मैम नेक्स्ट सेंटर से पूछ लीजिए कोई डाउट हो तो. हाँ, आरडी इंजीनियरिंग गाजियाबाद. You have any doubt with this? You can ask with related to circuit diagram or anything. Vijayawada College. You have any doubt? You can ask.
No doubt, sir.
Okay, sir. Thank you.
Dear Alok.
Sir.
What is the cost of this project approx? You have assembled it?
Sir, approx. I think, sir, 2,500 overall.
Okay.
Rough estimate, not exact.
Then you got this hardware all from Chandigarh itself?
Sir, some parts in the lab, in our lab, and some is my own.
That's very good. All these wheels and motors,
yes, sir.
And this arm.
Actually, sir, I am working from many years. I have interest in this field, so I collected these things earlier.
That's good. That's good. Anyhow, I'll come to you. I'll have contact with you.
Sir, you note down. You have noted my contact number, sir. I have written here.
Yeah. I have noted down.
Okay, sir.
Thank you. I'll come with my doubts.
Okay, sir.
Thank you, Alok.
Sure, sir.
Thank you. Good day. Thank you. Good day.
Next. College name? Government Polytechnic College, Maharashtra. You have any doubt here with respect to circuit diagram or anything? You can ask. Government Polytechnic, Maharashtra.
Alok, can you tell me a bit about this driver circuit? Driver circuit.
Yes, sir. L293. L293 motor driver, sir.
No, can you show me a bit catalog of it? Catalog of this driver.
Sir, actually, when you write L293 on the Google, you have the PDF of that driver, I think.
Okay. I will get it.
You can get from the Google.
I will get it. I know. I got it. Thank you.
Okay. Next, ma'am. Oh, complete. Okay. Okay, thank you for all.
Alok, just show me this program just once. Program.
Okay, sir. Okay. 1 minute.
Yeah, just program.
इसमें तो आर्डिनो इंस्टॉल नहीं है तो चलेगा नहीं एक्चुअली हाँ सर
बोलो आलोक मुझसे
sir actually Arduino is not installed in this laptop. This is the college laptop, so I have the file but it is not opened in this. The college or ma'am will mail you.
Sure. No problem. I'll discuss and come to you, right?
Okay, sir. Okay.
Yeah, I'll discuss with you.
Okay.
Thank you. Anyhow, listen, Alok. By the way, what are the books you are going to refer for this power kinematics, inverse kinematics?
Actually, sir, these are some books on the robotics in the library, and some are the main books are the.
Which you prefer good?
One is the Peter Cork's. The writer is Peter Cork, and robotic toolbox for MATLAB. This is the one of the. It is good book, and another is Vidyasagar and Spong robotics. Book name is Robot. Vidyasagar and Spong is the writer of the book Robot.
Okay.
Robotic control.
Right. Robotic control,
Yes, sir.
Right. Thank you. See you.
Yes. Which joints are used?
For connecting to links.
तो फिर यहीं पे इसमें मॉडल में बता सकते हैं मतलब जब वीडियो उनको यहाँ पे जैसे यहाँ से जॉइंट है ये एक जॉइंट यहाँ पे एक जॉइंट यहाँ पे
किस टाइप का जॉइंट है
इट इज revolute type joint revolute there are two types of the joint prismatic and revolute it is a revolute type of joint is there prismatic means a linear motion revolute means circular angular motion is there this is the whole system is on the angular motion any other doubts okay thank you to all next time we will discuss more about the robotics and with more of interesting things because college is going to purchase a robotic arm. Now I have to interface this with the many of the things, MATLAB and other software. We will discuss in the next time. Okay, thank you.
Thank you, Alok. Thank you.
Thank you, sir.
Thank you.
हाँ मैम को बुला देते हैं क्योंकि वैलिडेशन जल्दी स्टार्ट हो जाएगा तो सही रहेगा। हाँ मैम, आलोक जी बोल रहे हैं मैम। हेलो हेलो हाँ मैम, कंप्लीट हो गया है। हाँ हाँ ठीक ठीक है मैम, ठीक है, ओके ओके मैम। अच्छा अच्छा, हाँ तब तो चलता रहेगा तो सही रहेगा।
Dear Alok, are you getting me?
Yes sir.
हाँ. Alok, about the software.
Yes sir.
What's up? अब आपका नेक्स्ट कोर्स ऑफ एक्शन क्या रहेगा? आप क्या करेंगे अभी राइट नाउ फ्यूचर फॉर दिस आर्म?
अभी सर अब रोबोट आर्म जो 5 डिग्री ऑफ फ्रीडम का जो कॉलेज मंगा रहा है, सबसे पहले तो उसको आर्डिनो से इंटरफेस करना है कि उसको कैसे रन करना है। उसके बाद फिर एक वीडियो कैमरा लगा करके उसको इमेज प्रोसेसिंग करना है कि अगर ऑब्जेक्ट हमारा डिफेक्टिव है तो हम उसको कैसे एनालाइज करेंगे कि वो ख़राब है। उसके लिए प्रोसेसिंग सॉफ्टवेयर का भी देखना पड़ेगा कि कैसे करेंगे उसको। मैटलैब में भी होता है और उसमें लैब व्यू में भी इनबिल्ट है, तो अब हमें ये देखना पड़ेगा कि हम कौन सा यूज़ करें जो हमारे लिए सही रहे। उसके बाद हम
बट बिफोर दैट वी कैन गो फॉर मोशन कंट्रोल। नो, मोशन कंट्रोल भी तो करना पड़ेगा। मोशन कंट्रोल बिफोर इमेज प्रोसेसिंग, हमको वी हैव टू मोशन कंट्रोल।
एक्चुअली इमेज प्रोसेसिंग से जो आउटपुट आएगा हमारा, क्योंकि अभी मैंने पूरा एग्जैक्ट काम नहीं किया लेकिन मुझे ओवरऑल आइडिया इसका है, क्योंकि वो अभी मेरा थीसिस में अभी बाकी है करना, अभी स्टार्ट ही किया है। तो जैसे इमेज प्रोसेसिंग का जो आउटपुट आएगा कि ऑब्जेक्ट यस या नो में आएगा कि ऑब्जेक्ट खराब है या ऑब्जेक्ट सही है। ठीक है, अगर ऑब्जेक्ट सही है तो टेक नो एक्शन, अगर ऑब्जेक्ट खराब है तो पर्टिकुलर जहाँ पे खराब है वहाँ पे रोबोटिक आर्म जाएगा, उसको ग्रैब कर लेगा। तो ये
उस आर्म को कंट्रोल भी तो करना है। वी हैव टू कंट्रोल दिस मूवमेंट ऑफ द आर्म।
आर्म को रोबोट इससे कंट्रोल कर रहे होंगे, आर्डिनो से ही कंट्रोल करेंगे कि अभी भी आर्डिनो से ही तो कर रहे हैं कंट्रोल हम लोग। आर्डिनो से
कंट्रोल तो कर रहे हैं उसका इनर्शिया भी कंट्रोल करना है, उसकी स्पीड कंट्रोल करनी है. In beginning we have to increase, when it is going to touch the target we have to decrease. एक्सीलरेशन भी कंट्रोल करने हैं, स्पीड भी कंट्रोल करनी है, इनर्शिया भी मैटर करना है. सो दीज आर फैक्टर्स वी हैव टू कंसीडर.
हाँ हाँ सर, अभी इस पे काम करेंगे तो सारी जैसे जैसे प्रॉब्लम्स आएंगे उसको ओवरकम करते रहेंगे. अभी तो ये करना ही है, तो इस पे अभी करना है काम. अभी कंप्लीट है नहीं काम, कभी
My idea, before for this image processing, we have to control this movement. Otherwise, this head of the arm may break, may hit the target. Would you get the point?
एक्चुअली पहले सॉफ्टवेयर पे पूरा एनालिसिस करने के बाद ही बनाएंगे. अभी सॉफ्टवेयर पे एनालिसिस उसका पूरा मॉडल बनाने के बाद में कितना वेट उठा सकता है उसके बाद ही करेंगे. और वैसे भी सर प्रोटोटाइप अभी बना रहे हैं, ज़्यादा इस पे वेट का चीज़ नहीं उठाना है. बिस्किट टाइप ही कोई छोटा ऑब्जेक्ट ही उठाएंगे. ज़्यादा वेट उठाने पे उस पर ज़्यादा जर्क आएगा और वो टूट सकती है.
Anyhow, Alok, I want to discuss with you personally. Yes, so I will discuss. We'll take the time.
Sir, you are
I will take the time and come to you and discuss.
Sir, you are most welcome anytime.
Right, Alok. We'll see you.
Yes.
Thank you. Good day. Good day.
वीडियो चला दें कुछ. हाँ, तब तक चलता रहेगा तो थोड़ा सा हाँ, ऑटोमेशन इसकी चला देते हैं, जो एप्लीकेशंस वगैरह थी. इंगेज थोड़ा सा रहेगा. हाँ, दूसरी चला दे. जब तक मैम नहीं है तब तक तो
चलो आप आ जाओ, आप आ जाओ। चले दो
ये तुम्हारा रोबोट है।
Yes. All centers are there, na? Okay, so now validation session last है ना, हमने तो पूरा काफी बोल लिया पूरा वीक, अब आपके बोलने का टाइम है ना. लेट अस हियर फ्रॉम आवर सेंटर्स फर्स्ट. पहले ना पहले उनसे सुनना था. लेट अस begin with RD Engineering College. RD Engineering College. Yes, sir. RD Engineering College.
Hello,
Yes, sir.
I'm audible.
Yeah, we can hear you.
Good afternoon to everyone present overnight at Chandigarh and all the remote centers. First of all, I would like to thank you to give us the opportunity to organize this short-term course on industrial automation. Lecture delivery by all the expert was fantastic. All the participants learned a lot about the industrial automation, intelligent instrumentation, and all the topics that were discussed during this course. We hope that the same courses will be organized by you in future, and we will show our active participation in that also. And thank you for giving us the opportunity once again.
Okay, sir. Thank you so much.
आपका कॉलेज में लाइट नहीं है क्या? We cannot see your faces.
Actually, for projectors we have.
Okay.
Okay, sir. ठीक है. Thank you so much. Thank you. Next center, please. Vijayawada. Yeah. Yes, ma'am.
यही आती है हमारी.
Good afternoon, ma'am.
Good afternoon.
On behalf of PVP Siddhartha Institute of Technology, I would like to convey my sincere thanks to NITT Chandigarh and especially to Ritla ma'am for accepting our invitation, accepting our request and promoting our college as one of the remote center. And totally 38 members are benefited from this course, ma'am. Definitely it will be reflected on our student performance. And ours, we show our gratitude to Ritla ma'am with a huge round of applause. Please.
Oh, thank you.
Okay.
Thank you so much.
Thank you very much.
I really appreciate the efforts of Ritla ma'am for making this program a success. Thank you, ma'am.
Ma'am, I've given your contact details to Mr. Sunil Jassal also. I think you had contacted him that you want to make your center as a nodal center for his course in mechanical engineering department.
Okay,
So
ma'am.
I have forwarded your details to him also.
Okay, thank you, ma'am.
Thank you so much. MMU Mulana, Tripathi sir.
Ma'am, one more thing.
Yes. Ma'am, mic off हो गया आपका. Ma'am, your mic is off. Please turn on your mic.
Ma'am,
Yes.
where we get the PPTs and videos of your lectures and.
Okay, I will mail, ma'am. I will
Okay,
mail.
thank you. Thank you very much.
Okay. Yeah, MMU Mulana, Tripathi sir.
Very good afternoon, ma'am. My respected Lini ma'am, thank you very much. Actually, yes, your laughing is good because it's affirmative. I to repeat the same sentences. I am very much happy, and I to look after here and there whenever I will get a chance. I will not miss anyway and anytime. So overall, really, I know I am there with you since 19 years. Your best efforts towards the target, none of the target has gone back, and no doubt all achievements are there. I am very much thankful that I am there with you by all means. And today, our chief guest, Dr. Ricky Singhal sir is there. He is the depart from surgery professor from Department of Surgery from our medical college. We are all thankful that he could spare bit time with us. I was telling him that is that our university good luck is there. That most of the times we are getting the course over here, and it is being run with great success. So I am very much thankful, ma'am, and with your good team. Thank you.
Thank you, sir. So your certificates are also ready. The last course also, no? I have received only your list, so your certificates are ready. I just wanted to ask if somebody in the near future is coming from your college, he can collect it from me, or I can send it by post of the last course which was held on 14 to 18 September.
That I will let you know. That I will let you know. The mode of collection. Yeah, mode of collection I will let you know.
Otherwise, I will post it.
Yeah, I will let you know. Right.
Does your chief just want to say anything, sir?
Yeah. Just only line. Be on the line.
Good afternoon, ma'am.
Good afternoon,
So, myself, I am Dr. Ricky Singhal, working as a professor in Department of Surgery, and my specialization is in general surgery and surgeon. And nowadays, I am doing almost all of laparoscopic surgeries. For example, lap cholecystectomy, even renal stones we are doing laparoscopically. And sitting as a rural area, it's very, very difficult to do the laparoscopic surgeries. But almost we are doing all kind of laparoscopic surgeries and major kind of surgeries. And I want to congratulate to you and to sir to do a wonderful workshop, industrial automation. So congratulations. Thank you.
Thank you.
Thank you.
Government Polytechnic Bid, Maharashtra. No, sir, your mic is not working yet. Yes, sir. Yeah.
Hello.
Yes, sir. हाँ बोलिए. हाँ हमें आवाज आ रही है, बोलिए.
Thank you. Well, at the outset, on behalf of Principal Government Polytechnic team and principals of all associate colleges who have permitted their staff members to participate in this program. I thank both of you and United Liberty of Chandigarh Management for organizing a program like this and also accepting our request to become lead institute for our region.
सर थोड़ा सा माइक को अगर दूर कर लेंगे तो क्लियर आवाज आएगी, थोड़ा सा डिस्टेंस कर लीजिए। हाँ, अब बोलिए।
Okay. Madam, our institute is regarded to be the lead institute in the Karnataka region of Maharashtra, and we boast of leading at least 10 to 12 polytechnics in our district. Basically, we are into polytechnic education, which is regarded as 10 plus 3 level equivalent. So, what we would like to expect you to organize programs like we will be sending curricula of leading faculties like mechanical, electrical, civil, electronics to you over the mail. And if it is possible for you to customize your programs for different branches of polytechnics in Maharashtra, then we can form a guild and for which you can have a customized program. If something like this happens in the future, I think not only staff but directly and indirectly students will also get benefited.
Sir, let me break out what you have said. Are you trying to say that you want customized programs and want us to come there and teach? Is that what you want?
That could also be one of the ways. Right now, what I expect you to think is that we can, what we can do, we can communicate, we can send our curricula of important skills to you, and based on those curricula, there are certain advanced topics which we will be listing and mailing to you.
Okay.
And if you identify institutes from Maharashtra, basically polytechnics, then you can these programs for our state.
Okay.
That's what our request is.
Students.
No students, staff.
Faculty.
Staff, yes.
Okay. Okay. Let me again convey what, if I have understood what you are saying. You are saying that you will send your advanced topics of your curricula to us, and we specifically plan our courses for polytechnics of Maharashtra based on those topics. This is what you're trying to.
Yes,
Yeah, that can be done, sir. That can be done. Send us mail, and what we will do is we will include such things in the next O plan.
Exactly, because that will improve our teaching quality.
That is perfectly fine, sir. That can be done.
More ICT चाहिए connect.
हाँ, नहीं, you want ICT based, ना?
Yes.
Video conference. It will be done, sir. It can be. No issue.
It could also be practical. That means your staff members would be coming down to field and we will organize program.
I got your point, sir. I got your point.
That is also a possibility. And last but not the least, as far as current program, that is industrial automation is concerned, we all participants, total 13 participants, are more than happy to be part of this program. This is first program for me to become a participant for this particular event, and we all teachers are very much confident that the knowledge which we have gained over the last 5 days would certainly help us to get engaged in our attitudes as well as regular teaching practices.
Thank you, sir. Thanks a lot. Thank you for your encouraging words.
And I also have your backstage artists who we could not see because they also helped me a lot and made this program a successful event. Once again, thank you from Government Polytechnic team. Thank you very much.
Thank you, sir. Thank you. Now, can we move to Vaknaghat Center, please? Yes, sir.
Good afternoon, ma'am.
Good afternoon, sir.
Ma'am, the workshop was very wonderful. Actually, you people are doing wonderful job and making these workshop just giving us a crystal clear picture that how we can indulge our students in such things which you told in the last 5 days. And I really thankful to Dr. Lini Matthew and you, ma'am, Miss Rachela Thakur. And ma'am, one thing I just want to know, in future, if we want to conduct such workshops, how we can come to know from your side that on such topics you are organizing the workshops or not?
Sir, in our website www.nitrrchd.ac.in. We have O plan for the whole year, operational plan for the whole year. There are 3 options there. One is for engineering colleges, one is for polytechnic. Sorry, one is for this ICT based, and the other is contact based.
Interdisciplinary.
So what you can do is, in case you are interested in ICT based courses, you can specifically go to ICT. Therein you can select which branch. Some courses are interdisciplinary. Like this one was interdisciplinary, anybody from any branch. So accordingly, you can see for the whole year also. You can see for the month wise also. It is available in our website, nitterchd.ac.in.
ICT based courses.
ICT, these are ICT based courses.
Okay, and one thing more, ma'am. I just attended one workshop there. It was basically from the our HP Regulatory Commission. At that time, I visit NITER, and I just want to know if I want to make my students to visit over there in your campus. Then what is the procedure for that, so that they can learn about the things and what the students are doing there? I just also want to know about that.
Bring them to me. Which way should we take the money?
I don't know. Visit के लिए कैसा है? Students का visit के लिए? I think, sir, what you can do is you can drop an email to director, sir.
Okay.
Then I think he will be, because I can't comment on it. I've never organized such visits, but in case you are interested, you can drop an email to our director, sir, and then you can sort out the things.
And ma'am, one thing more, I want to know if you are giving certificates for these things. For this workshop, if you are giving some certificate, then
of course, sir.
How we can let you know that how many of us attend this workshop? Is there? Shall we email you or something else?
I will tell this to all the centers. In fact, what is the next course of action? What I will do is that I have the email IDs of all your coordinators of each center. I will send you a performa. There is one performa in Excel sheet. So what you do is you send me the name of all the participants in that Excel sheet, and then I will make the certificates and dispatch it.
Right, ma'am. Thanks a lot, ma'am. Thanks a lot.
And also you have to send the bills also. The bills and attendance sheets.
Okay, ma'am.
With signatures and stamp and everything.
And there should be counted by the local coordinator and principal also.
So rest of the thing, you may note down my number. It is 9885 202 84.
9885
Right. You can call me and inquire in case you need any help.
Right, ma'am. Thanks a lot, ma'am.
Okay.
Thank you.
Our participants here. Would you like to say something?
All centers are over.
5 थे ना? बोलिए.
It was very much informative, and I have gained many practical knowledge of the instruments which I haven't seen in before. Because I
You're from mathematics,
different stream. But it is a very good practical knowledge for me for seeing the working of these instruments. Thank you.
Anji, for you from the branch.
बोलिए.
हमको निकलता ही है, हमें कुछ बोलना नहीं है.
Especially the sessions of Mr. Chatterjee, they were very informative, and one session you organized on PLC, that was the programming concept was very nice. Rest of the sessions also by Dr. Bhagan Kumar, that session on automated decoder testing. So overall it was very nice.
Okay, thank you. Now I would request my HOD, Dr. Mrs. Lini Matthew, to please say a few words.
Dear participants here in the center and at various remote centers, good afternoon to all of you. It is nice to hear that all of you are very satisfied with the program, and I congratulate Ritula Thakur for her efforts in taking classes and arranging experts from various fields. I knew that before during the planning itself, she was discussing me about the experts she was calling, and I knew that it will be a good course because the experts also are very experienced and well versed, especially Chatterjee sir, Amod sir, Baban Kumar. So I hope that, and I heard from you also that you got good information from all these experts, all these lectures, and it will be very good for you. And I congratulate the centers which have been connected with us for the first time from Bid, Maharashtra and Baghnaghat for your encouragement. I say that you can contact us hereafter also, so that we will be in contact with you again and again. You can connect with us for other courses also, other departments also, and I hope that such courses of ours will be more useful to you. Thank you very much, and hope we have more associations with you in the coming days. Thank you.
Last, I would like to extend my formal. Yes, anybody would like to say something?
Yeah, myself, Akhilesh.
Yes, sir.
Ma'am, any course related to our medical college from this NITDT?
Yeah, Akhilesh, you know that we are a technical institute. We don't do much courses on
We don't
medical
have expertise in that.
But ma'am, for this biomedical, right? Some course can be run by biomedical. So both of us, our medical college and engineering college, they can take the benefit. And this should be some integrated one. So rather biomedical, it's an emerging field. So we will very much thankful because in our campus, a very big medical college there. So we can take some participants and we can organize well.
So that's a very good solution. But the thing is that we don't have expertise in biomedical. I'm an embedded system engineer, specialized. Ma'am is working in artificial intelligence power system. We don't have a specialization in biomedical. Maybe in future, if some faculty joins us specialized in biomedical, maybe we can arrange such kind. That's a nice suggestion, well taken this. But as of now, we don't have expertise in that.
Right. Thank you.
Last but not the least, I would like to extend a formal vote of thanks. I am thankful to my HOD, Dr. Mrs. Rini Matthew, my colleagues, Dr. Mrs. Poonam Sial, Mrs. Shimi, and all my department who have directly and indirectly contributed in the successful completion of this course. I am also thankful to my student, Mr. Alokdi, for taking this wonderful session on robotic arm, and Mr. Amandeep Sharma, our PhD research scholar. I'm thankful to our experts, Dr. Chatterjee, Dr. Baban Kumar, Dr. Amod Kumar, who have come on our request and given sessions, and from NI also. And I'm also thankful to my ETV department, who have given us the facilities and also helped us in, without whose support this ICT based program was not possible. Last and not the least, I would like to thank all the centers and their participants for being such a patient listeners, and because of your encouragement and because of your active participation in this course, it was because of you that we got encouraged and could give our best. Thanks a lot.
Thank you very much. Thank you very much.
Okay.